I'm Dr. Padilla, and in this video series, we have been talking about transforms in Vega-Lite. The next one on our list is the join transform. Now, full disclosure, join is not as easy in Vega-Lite as in some other programming languages, including R and Python, but I wanted to show you a real-world example to give you a sense of how it would unfold. Now, if you've been following along, the data set that we have been working in looks like this. And what we have is countries, years, disasters, and then the number of deaths in that particular country. Now, I have added an ID to this data set, and I will show you why. The reason is what we will like to do is we'd like to combine this data set with this one here. It has very similar fields, except it has economic damages, and this indicates the dollar amount of economic damages for these various disasters, and it also has an ID. Now, I've created the data set in such a way where the IDs line up from this data set to this data set, and we will use that to join these two. Now, before we jump in, I wanted to give you a sense of what this data looks like. So what we have here are two different dot plots, and they are showing the different disasters here on the Y, year along the X, and the size indicates the value that we've been looking at in each of these two. So the top one is total deaths, which we've looked at before, and the bottom one is total damages. And when we start to look at this, what we notice is that over time, in terms of total deaths, the number of total deaths is going down all across the world, really. And we can also see the different types of disasters that have the higher proportion of total deaths, including droughts. This is sorted such that the natural disaster with the highest deaths is at the top. Now, in contrast, when we're looking at total economic damages, we're actually seeing that go up over time. So while deaths are going down, economic damages are going up, particularly for storms, and this includes hurricanes. But what we want to do is try to find a way to combine these two data sets to contextualize them. So this is the actual code for the first data set, and go ahead and pause the video now and copy this, or I will also leave this code in the comments section. But I'm going to copy this and use it to start our joined version of our visualization. Okay, so we have a basic copy of the previous version. Now what we're going to want to do is begin the join process. And this can be a little bit complicated, so bear with me. But what we'll want to do to begin is we want to add a lookup function. And we're going to do that right here, right before we start to do this aggregation. Now, just to kind of give you a summary of what this code does, initially we are pulling up the data, and this is in the GitHub repository. And then we have a transformation right here, and this transformation is grouping by year and disaster. And then we are creating some aggregate values. In this case, what we're doing is taking the sum of deaths and we're saving it as total deaths. So we can refer to it later down here. And then we are encoding that information using the X value, and we're encoding year here. The Y value is encoding the disaster, and it is sorted based on total deaths. That's how we're getting this Y sorting. And then we have the size also encoding the disaster. And we have a width here, and then we're just rendering our plot. Now, what we'll want to do is begin by top of our data set adding a lookup function. So I'm going to start this right here. Give myself some room so we can see it clearly as we start to get a fairly complicated plot going on here. So we'll do vl.lookup. And I'm going to add in placeholders for the different values that we're going to add. So for this function to work, we're going to need a from call as well. And then within that, we're going to need to specify some data. Don't worry, we'll fill these in just a second, and a key and some fields. So let's walk through what we have going on here. The first is we are wanting to look up something, and then from the thing that we looked up, we are going to then add another data set to it and specify a key that will help us link the two, and then the fields is going to be the new values. So let's go ahead and add some information in here so you can kind of get a sense of what we're going to do. So in our lookup, what we're going to actually look up is ID. And this is going to be the key or the value that we're going to match from this first data set to the second. Notice that ID matches across the two. So we'll specify ID here, and we're going to look up that from a particular data set. So we're going to add the code for a data set in here. I'm just going to copy it over so I don't have to type it all out, but we're specifying a URL, and then this is the link to this secondary data set. So we have our first data set here, and we are looking up a value and associating it with the second data set. Now for the key, what we have to add is from the second data set what it's going to be connecting to. In my case, these two terms match. These two names of fields match, but you don't necessarily need to make them match. You could have ID here and a different word here. In my case, they do match. The thing that absolutely has to match is the values of the field itself. So you have to make sure that these are perfectly matching the values associated with the field. And then the last thing we are going to add here is then the field that we are going to add from the second data set to the first. So essentially it's going to be as if we have this main data set, and then we're going to look up ID, make sure those match, and then add a field from the second data set to the first data set. Now the field that we're actually going to add is this economic damages field. That is all we really need to connect to these. And, when you're doing this on your own real world data set, this can be very complicated. And what I actually found is that it was very challenging to connect this data set using country, year, and disaster. In theory, these values actually match across these data sets. What I ended up doing was adding a unique ID to both of these that matched, and it was a little bit easier to connect it that way. So just fair warning that you might run into a little bit of issues if you're trying to use several different IDs and keys to match these data sets, whereas that would be pretty easy in R and Python. Okay, so those are connected. You're not going to see anything special going on here because we're just visualizing this data and not the connected data yet. So what we'll want to do in this section where we have our aggregate function is we want to do a second aggregation for this economic damages value. So I'm going to make sure that we can put this on a list. And then I'm going to add vl.sum and then economic damages. And we'll save that as, let's call it total damages. Messed that one up. Okay. All we've really done here is we have created another aggregation where we are summing across economic damages, and we want to make a new value called total damages along with the sum that we made for deaths and the new value that we've created called total deaths. Okay, let's go ahead and run this, see what happens. Nothing happening yet, right? Remember, we're just doing all of this transform kind of in the back end with the data. What we're still encoding is the same information. We haven't changed the encoding at all. So let's just see if any of this has worked. One thing that I like to do to see if I'm making an impact in any way with some of these more complicated transforms is to add a tooltip. So I'm going to add a tooltip, and the tooltip I'm going to be adding is a quantitative field, and it is going to be for our total damages here. If we run that and we hover over this, notice that as I'm hovering, it's giving us a number, and this is actually the number of total damages. You can see here that there's 0. If we look back at our original graphs up here, there was really no damages for these droughts in the 20s. But there certainly are for these natural disasters that happened more recently. So if we scroll over these little teeny tiny ones, you can see it's very, very large numbers, but smaller numbers here. Now, I don't know this data set well enough to know if these 0 numbers are truly 0 values or if that was just before data was collected. It seems quite surprising that if there were, somewhere around 300,000 deaths, there would be no damages. But in any case, you can take a deeper dive into this data set. Just to summarize what we did here by connecting these two data sets is we, inside of our transform, we added a lookup that's looking up the ID. We added a secondary data set and made sure and connected the ID and the key here. And then we specified the additional fields that we wanted to add from the second data set, and that can provide additional information here. Now you might be inclined to do something like add color to these circles to encode the total damages. And what that would do is for these little teeny tiny dots here, these are really where you'd be seeing the differences in colors with the higher damage values. So I didn't do that just because I think it would be very, very hard to read, but you can play around with some additional encoding channels yourself to see if you can find new ways to visualize both of these two data sets together now that you know how to combine them.